Hi guys, this is the first time I've had to record a lesson for you at home. I miss you guys. I miss being in the classroom. So it's going to be a little different today because I have to use my mouse instead of my smartboard. So what I'm writing might not look the best, but we're doing our best. So today's lesson is chapter 8, lesson 3, finding the area of composite figures. And I'm not going to lie, this can be a little tricky, but we'll get through it. So let's get started here. Okay, so here's the deal. Your book thinks that you remember everything that you learned last year. They think you remember how to find the area of triangles, area of parallelograms, area of trapezoids. So we have to go through that stuff before we even get to the actual lesson for today. So a few things you have to remember is to find the area of a triangle. There's two equations you can use for it, but a lot of times students will pick this one right here because it's the easiest one to use. A lot of times people don't want to use the fraction, so they decide to divide by 2 instead. So the equation for the area of a triangle is b times h, b meaning the base, which is down here, and h meaning the height, which is how tall it would be, and then divide by 2. So a lot of times people tell us what the equation is, but they don't explain why it works. Well, the explanation is that every single triangle is half of a square, and we know that a square, hold on, let's see if I can get it here, a square, come on, let's see, square, let's pretend that's a good one. The area to find a square is also the base times the height, b times h, and then we divide it by 2 because a triangle is always half of a square. So there's a triangle right there. So that's why it works. It works for every single triangle. It does not matter what the triangle looks like. But oh, see, it's all trial and error here. I wanted the eraser. I was using the shortcuts before. Now let me use that while I'm recording. Okay, so if I calculate this one correctly, it would be 30 times 12, and then dividing by 2. The answer for here would be 180 inches squared. We always square area all the time, so this would be 180 inches squared for the answer. So let's go to the next one here. See, this is a different looking triangle. It's the same thing. You're going to take the base times the height, which would be the base would be 17, the height would be 9. So 17 times 9, and then we always have to remember to divide by 2. And let's see if I calculate this one correctly. Remember, I make mistakes, but we're going to try it anyway. 17 times 9 is 153, divided by 2 is 76.5 yards this time, yards squared. So that's how you find triangles. Next thing we're going to go to is parallelograms. Now, if you remember before we left, we talked about parallelograms. They were on the board. Remember, we talked about about 6 different types of quadrilaterals, and this is one of the quadrilaterals. Now, the cool thing about a parallelogram is the area is super easy to find. Now, look, it's just base times height, and if you remember right when we talked about squares a few seconds ago, that was how you find the area of a square. Now, why does this work? How can you find the parallelogram and the square and to be the same way? Well, here's the cool thing. If you would take this guy right here, let's say you cut him off and you move him over here, he becomes a rectangle. And a rectangle is also found the same way, just like this. So for any parallelogram, base times height, so this would be 7 times 5, and this would just be 35. And we'll say it's inches. I don't have anything there. Inches square. So pretty easy to find a parallelogram, base times height, just exactly like a rectangle and a square. This is the same way. This is another looking parallelogram, just a little taller. Remember, everything might look a little different, but still called the same thing. This would be 9 times 7 times 9, 9 times 7, 63. We'll call this one yards this time. Square. That's how you find parallelogram. The next thing we're going to find is a trapezoid. Remember, trapezoids, they were kind of the odd man out when we talked about quadrilaterals. So they have another different type of equation. It's not like a rectangle and it's not like a parallelogram. It looks a little different. So there's two you can use. You can either use this one or you can use this one down here. And I bet you can guess which one people use most, and it's actually this one because they don't want to deal with the half, the fraction. So what do some of these things mean? Well, this B right here means a base, and this one also means a base. Now, in a trapezoid, we have two bases. We're considering this a base, and we're considering this a base. So one of these can be considered B1, and one of these can be considered B2. Okay? So here in the height would be this. This would be our height, how tall it is. Okay, so what we're going to do first is we're going to write our height, and then we're going to do B1. And remember, this is a plus sign. I have a lot of times people forget that and they make it a multiplication sign. So we're going to take base 1, which is 7, plus base 2, which is 10. And then we're going to divide that whole thing by 2. So what I would do first is I would do this top part. So let's see, this would be 5 times 17. Okay, which is 5 times 17. Let me see. 5 times 17 is 85. And then I would divide by the 2. You have to do the top part before you do the divide by 2. And then you get 42.5. This is, I don't have anything, so we'll just say inches squared. So you have to be careful with your base 1 and your base 2, and remember it's a plus sign in here. A lot of people don't understand really why this works, and I can quick show you if you want. Let's see, get to my big eraser. Wow. Okay, let me show you why this works. So first I'm going to put, where are you, shape? Let's put a new trapezoid here. Okay, all right, and then I'm going to click on that guy, and I'm going to clone him and make a second one. Okay, I'm going to turn them around, and I'm going to put them together. Now, if I look at this shape, it looks just like a parallelogram. Remember, a parallelogram was the base, like this base, times the height. Well, my height's still the same, but my bases are basically base 1 and base 2 put together. So it'll be like having my 7 here and my 10 here, and my 10 here and my 7 here. And I can take my height, my 5 times my base, which would be 17. And then I got to divide by 2 because really I'm only looking for one of the trapezoids. So it's actually really cool, and I wish somebody would explain this to me when I was young. But it's pretty interesting how it works. So let's try another one. Here's another type of trapezoid you can see. Remember we talked about the two kinds. So this is one that looks a little different than the other one. So if you remember correctly, we're going to do, let me find my pen. It's height, and then base 1 plus base 2, and then all divided by 2. So in this case, the height's going to be 10, and then base 1, you can do 8 or 12, it doesn't really matter, you're going to add them both together anyway. 12 divided by 2. Let's do the top part first. Let's see, 8 plus 12. We can do that in our head. 8 plus 12 is 20. 20 times 10 is 200 divided by 2. So it's going to be 100. We'll do inches again. Inches squared. I can't remember. I was gonna remind you to do. Oh, a lot of times people, will forget to divide by the 2. So don't forget to divide by 2. That's the last thing you have to do in this problem. You have to make sure you divide by the 2. All right, so that's what your book thought you remembered from last year. It's kind of comical, really, that they don't even go over this for you again, really. I think in the book they give you the equations, but they don't give you some examples. So I knew I had to go over some examples for you. So we're going to actually get into the lesson now. So it's called Irregular Figures, finding the area of irregular figures. And I guess my question to you is this: what do you think irregular means? Think about what the word irregular means to you. Kind of to me, I've been thinking about this. To me, irregular means out of the ordinary. So we're going to see kind of out of the ordinary shapes today. We're going to see shapes that look like shapes, but isn't a shape we can call a square or a rectangle or a triangle or a circle. It's going to be shapes that are kind of put together. And so our job, let me put that up here, our job is to find the area of a shape like this. Now, it can be kind of overwhelming, but if you follow the steps and keep yourself organized, like organization is the key. You have to keep yourself organized and stuff like this. So let's just go over like how we would start this. So like the step one, when you see your irregular figure, the first thing you should probably do is split it into some things you know. Now, what I split it into and what you split it into could be totally two different things. Like if I look at this shape right here, if I had to split it up, this is how I would split it. I would split it into three, well, this kind of looks like a square, but three different shapes. That's what I would split it into because that's what I see first. Some of you don't see that first. Some of you might see this first. Might see this, this, and this. That's fine. You can do it that way. Some of you might not see it that way. Some of you might actually see it like this. You might find the area of the rectangle and then find the area of this and then subtract it out. That's another way too. I mean, there are so many ways that you can split things into. So don't think what you do is wrong because it's probably not. So if I look at this one, I think we probably all about see the same thing here. Let's see, where's my pen? I would split it probably into something like this. I see a triangle and I see a rectangle. That's probably the easiest thing to split that into. Let's see. This one, there's a few things you could split this one into. What do you see first? Think about what you see. I see it like this. I see a rectangle and a triangle. That's something you could split it into. Something else you could split it into. Let's see. Something else you could split it like this. You see like a square rectangle or a trapezoid. Some of you would even go farther and split it like this and see three things. Honestly, don't split it into too many things because it's going to get too confusing. If you can split it into two things, leave it at that. Don't split it into more things if it's not necessary. You don't want to split it into too many things because otherwise it's going to get too confusing. So split it into something that you see. Maybe if it's two shapes, be two shapes, three shapes if you need it, but I would not go over three if you don't have to. All right, so what's second step? So second step is find the lengths of all the sides. So let's say this is my figure, which I kind of just showed you before. And what you have to do first is you're going to split it into two figures. So let's go back and let's split it into two figures. And I'm going to split it like this just because that's what I see it as. Now, if you split it into something else and find the area, guess what? It's probably going to be the same answer. So don't worry about it. Okay, so what does this mean? Find the lengths of the sides. Well, I have two things here. And what I like to do is I like to see what I have. Like, so if I have a triangle, what is the area of a triangle? Well, base times height, b times h divided by 2. Okay, so what do I know about this triangle? What do I not know? Well, I don't know anything about this triangle. I don't know the base of it, and I don't know the height of it. So I have to use some of these measurements in here to figure that stuff out. So let's start doing that. So I know this whole thing is 20. I know this whole thing is 10 on this side. So if this is 10, then this has to be 10. Then what do I have left here? If this whole thing is 20, this also has to be 10. Okay. And then, so I have my height. Now what about my base? Well, if I know this is 15 down here, you can see this guy, he's 15. And he's 7 here. How can I figure out what I have left over here? If this is 15, this whole thing should be 15. This is 7, this has to be 8. So now I have everything I need to start solving my problem. Now what's my next step? We aren't solving yet. My next step is solving. Okay, so here's my step 3. Now here's where you have to be very, very organized, because if you're not, you're going to get confused. Like for the next how many lessons, I'm going to talk about organization, 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 because it'll keep your life very, very simple and very easy if you know exactly what you're doing. So let's say I just did this. This is what I did. I found on my last page, I found 10, I found this was 8. So here's how you can keep yourself organized. What you do is you number your shapes. I numbered my rectangle 1. I numbered my triangle 2. So now I'm going to go to my rectangle. I said, okay, number 1 was my rectangle. How do I find that? I wrote out my formula. Below, I did the work. So, okay, so my base was 15, my height was 10. Oh, the area of my rectangle is 150. Now let's do the triangle. Triangle was 2. I wrote triangle. Then here I wrote the equation, or you could do b times h. I'm more comfortable with that one also, divided by 2. Okay, well, here's what I could do. My rectangle, or my triangle, I'm sorry. My base was 8. My height was 10. Divide by 2. Guess what? My triangle is 40 inches squared. Okay, now the last step you have to do, if they want to know the area of the whole thing, you have to take these two things and you need to add them together. There you go. That's your area of that whole thing right there. So do you see how it's so important to keep yourself organized? Because here's your rectangle, you did that. Here's your triangle, you did that. Now add them together. Let's do another one together. Okay, so here's my next irregular figure. There's a few things that I could do here. I could split it right here, and I could have a rectangle, and I could have a trapezoid. Let's see, I could probably split it. I could split it 3 ways here and here, and I could have a triangle. I could have a rectangle, and I could have another rectangle. There are so many ways that we can do that, but I like to keep it simple, and I'm going to split it into 2 shapes, and I'm going to split it right here. So I have a trapezoid. I'm going to label that 1, and I'll label this 2. Now we have to make sure we find all of the sides that we need to find. So let's do that next. Let's find all of our, I'm going to change my color here so we can see a little bit better. So here's my rectangle. We'll start with this one. So we know if this is 10, this has to be 10. Okay. And now we have to find the height because we don't have a height here. Now that's pretty simple. If you look on this side, what's this whole height? This whole height is 8. Oops. This whole height, I'll just go over like 8. And if we know this is 4, what does this have to be? This has to be 4 because 4 plus 4 is 8. That's the whole height of that thing. Okay, so we have the rectangle. Now we have to do a little thinking here because it told us that this whole thing on the bottom is 22. I know this is 10. So if this whole thing is 22 and this part is already 10, what does this part have to be? It has to be 12 because 12 plus 10 is 22. Okay, so let's start. So my first one was my trapezoid. And I know that it's height and then B1 plus B2 divided by 2. All right, so my height was 8. And then my base one was 8 up here. We'll use this as a base 1 plus 12. That's my base 2. Parentheses divided by 2. Okay, so it'd be 8 parentheses. That would be 20 divided by 2. So it's going to be 160 divided by 2. So my trapezoid is 80 meters squared. Check out that writing. 80 meters squared. My rectangle, okay, rectangle. Ooh. My rectangle is 10 as base times height. I'm sorry, I like to always write out my equations so I can see what I'm doing and what I have to fill in. It makes it easier so I know. I always do that, and I'm the teacher, so I know some of you will need to do that too. So my base was 10 for that rectangle times that height, was 4 equals 40. Woohoo. So if I want to know the whole thing together, I got to take this plus this, 80 plus 40, be 120 meters squared, or whatever, yeah, meters. Okay, what do you guys think? Think you can do that? I think you can do that. I hope I have everything right here. I hope all my math is correct. I don't have you guys with me in class to tell me if I'm not right. Sometimes I miss that. Okay, let's keep going here. Let's keep going. All right, so here's another one. This is, I think, one of my last examples. And if you look at this, one thing we didn't talk about in this lesson today was the area of circles. But we did talk about that last week. So the area of circles is, if you remember, is pi radius squared. Okay, but if you look at this, we're going to pretend this is a semicircle. Now a semicircle, if you remember correctly, what do you have to do to find half of that circle? You have to find the area and divide by 2. So you might have to use what you learned about circles in this lesson also. So let's see, we'll make this 1, we'll make this 2. Okay, so my rectangle was base times height, so 20 times 6 equals, let's see, 120. I didn't write anything, we'll do yards. Yards squared. Okay, and then we got to do my semicircle. Ooh, semicircle. So we need to have pi, which is we're going to use 3.14 times the radius. Do you remember what the radius? What would the radius be here? If the diameter is 6, the radius is 3. So times 3 times 3, because it's radius squared. Remember, it's radius times radius. So let's do that first. Let's do pi times 3 times 3. And that is 3.14 times 3 times 3 is 28.26. And we have to divide that guy by 2. Oh, no, that's not what I wanted to do. Equal, and then divide by 2 is 14.13. We'll do our yards again. Yards squared, and then we have to add these two together. Add them together, and it's 134.13 yards squared. Okay, so like I said, as long as you keep yourself organized and remember your formulas, you might have to look back at some of them, and that's fine. Use if you need to look back. And honestly, you can use a calculator for some of this today. As long as you show me what you're doing, use a calculator to help yourself out. I must be missing a line there. Okay, so here's a little story problem for you. Let's say you want to carpet a room, but a small 6 by 6 foot square is already carpeted. So let's say it's right here. Let's say this is our room. Let me fix that because that's bothering me. This is supposed to be like this. Okay. Some of it's already carpeted. Find out how much carpet we need for the room. Well, first of all, we're going to have to split it into some things that we know. Okay, so the easiest thing I think for this would probably be just to split it so you have 2 of the same up here and then a big rectangle in here. We're going to forget about this part that's already carpeted, and we're going to find the area of the whole room first. Okay, so we're going to do 1, we're going to make this 2, and we're going to make this 3, and we have to see what we need to know here. So for side lengths anyway. So if I look at these up here, it looks like this is 8 and this is 10. And I'm going to assume this is the same thing. I'm going to assume this is 8 and 10. And then what we have to figure out is if we know this whole thing is 18, we just need to know this part now for that rectangle. So if this is 8 right here, because if this is 8, then this has to be 8. So the rest of this would be 10. And then all the way across, like, okay, now we have to figure out what the base is, but if I look, if it's 10, 10, and 10, this whole thing has to be 30. So you have to kind of look at some of the other things. That's probably the hardest part, is to figure out what the other side lengths are. You have to use some, some thinking a little bit. So let's talk about our number 1. Let's see. So up here would be 10 times 8, and that's 80. And then my second one is going to be the same thing, 8 times 10, 10 times 8, and that's 80. Okay, my number 3 is a rectangle, which is going to be that 30 times that 10, 30 times 10, which is going to be 300. Okay, so now we're going to add them all together to see what the whole thing is. So 80 plus 80 plus 300 is 460. Okay, but if we go back to the problem, do we need to carpet the whole room? No, we don't. We have some part in there that does not need to be carpeted. So what is this part here that doesn't have to be carpeted? Well, it's 6 by 6 feet, but how much area is that? Well, I know 6 times 6 is 36. So I know 36 doesn't have to be carpeted. So let's subtract 36 out. And so we really only need to carpet 424 feet of this room, feet squared. Oops, here we go. So that's today's lesson. I don't think I have another sheet. Nope. Okay, so a few things you need to remember. You need to remember that you need to stay organized in your problems. You need to remember that when you split up your irregular figures, that you split them into the least amount as possible, because otherwise you're going to start getting confused. The hardest part of this is going to be able to find some of the side links that you don't know. So do your best. On your homework today, I'm going to give you a worksheet. Let's see. Do I have it up here? No, but I will find it. Let me find it here. Okay, this is your worksheet. This is what it looks like. I only want you to do try the first 6. 1, 2, 3, 4, 5, 6. Notice that some of these shapes in here, here's a rectangle and a triangle, here's a semicircle, and these are some things that we just did. This one right here, you can see a trapezoid, and you can see a parallelogram, so I'm helping you out. This one right here, you could do 2 triangles. You can do this triangle and this triangle, 2 semicircles, and then here there's 3. There's a trapezoid, a rectangle, and a rectangle. So seriously, just try the first 6 and we'll see how it goes. Okay, you can do it. Make sure you keep yourself organized. And if you have any questions, let me know. This is a lesson that a lot of people have struggled on in the past for me. So just do your best. Look back at your formulas, and I hope you wrote some of them down so you can see them. Like I said, if you have any questions, email me or write me on Google Hangouts. I miss you guys. I miss seeing you in class every day. It's been a long few weeks, and I know it's going to be a kind of a long rest of the school year, but we can do it. So if you need some help, please let me know. See you guys.